Welcome everybody. Welcome to JEDI Discussion. These are direct, crisp conversations with leaders in technology and science. My name is Ongaro. I'm the director of JEDI. Apparently, we have a few sound problems, so I don't know if an echo here. Can we try maybe Franco to put on mute?
I'm trying to reduce a little bit. Let's see. Is it better like this?
It sounds better, yes.
Good.
All right. So, obviously, technology is always unpredictable, but we seem to have a little bit of time. So let's continue like that. As you know, JEDI is the European Initiative for Disruptive Innovation. We are launching grand challenges on major societal issues like healthcare, environment, digital, and obviously ocean and space. We call that New Frontiers. And we are today absolutely delighted to have Franco Ongaro with us, who is the Director of Engineering, Technology, and Quality at the European Space Agency, one of the leaders of ESA. And we are absolutely delighted, Franco, to have you with us. Welcome.
Good evening to all. Thank you, Andre. It is a pleasure to be here with you, and it's a pleasure to be with all. I hope you managed to hear me well. If there's still some problems, I must admit it's the first time I use this program, so sometimes it doesn't exactly work as we would expect.
I think the sound is perfect, so I think we can continue. I think the problem is on my side, but you will do most of the talking, so it's not a problem. So you're a key member of the European space community. So let us dive immediately. Tell us, I mean, when we hear about space, it's about the last frontier, it's Star Trek, but it's also everywhere. Tell us a bit how space is part of our everyday life.
Well, for me, it's always interesting to make people realize how much space is already part of their normal life. And if you take your normal day, you wake up in the morning and perhaps you turn on the TV, and your TV is getting a plug from the wall. So what does that have to do with satellite? All TV actually goes through satellite. When you see it, because anywhere you see a television crew filming, they have a van with a satellite because they cannot carry a cable with them. And therefore, anywhere you are, wherever you get your TV, it's been through space at least once, the signal. Now, maybe on TV, you look at the meteor. That also comes from satellite. Last year, we sent a satellite called Aeolus, which is the first machine in the world who was able to profile winds from 30 kilometers up all the way to ground all over the world in a week. And that improved so much the weather prediction that EUMETSAT has decided to use it operationally already, even if for us was just a research instrument. And they tell us that about 50% of their prediction capability comes now from satellite data. But okay, you go out, you want to go to work, you take the car, or maybe you take the bus. Well, navigation. The bus will tell you how long it will be there. Your car will tell you where to go, maybe even your bicycle. Thanks to navigation satellites. And Galileo, the European program that we built together with industry for the Commission, it's 3 times more precise in location than GPS. And this is thanks to atomic clocks, and atomic clocks that we've reduced to the size that can fit on a satellite. And of course, once you navigate to work, perhaps you work in the stock exchange, that's using satellite navigation clock timing for its timing. Perhaps you work in the building industry. then you use satellite pictures and synthetic aperture radar interferometry to see the difference in subsidence of your buildings. Or perhaps you go out to sea. And then our Galileo, with a system of search and rescue, will be able to save even more than the 1,000 lives per year that we already save in this way. I think almost any, from agricultural to fishing, etc., almost anything you do, logistics, will be making use of satellite communication, satellite navigation, pictures from satellites, Earth observation, in order to make your job feasible and competitive. But it's not only that. You come back in the evening and you want to see whether your hotel is near the beach or near the ski lift. You go on Google Earth. Many of those pictures come from the European Space Agency, and you make your choice. And then you go to bed, and your security forces, your fire brigade, etc., will be connected by satellite if anything happens. So that's a little bit.
You mentioned to us a couple of examples that were linked with climate. It was very impressive during the COVID crisis. We saw this satellite picture of, for example, China during confinement and before, where we saw the pollution level. Tell us the relationship between space and the major challenge ahead of us, which is climate change.
Well, I think the first and most important things to say is that Europe is today, thanks to the Copernicus, the largest provider of satellite data on the environment in the world. We are vastly more informed than our colleagues in the US or in Russia. One of the things which I think is particularly interesting, and this is a satellite we launched a couple of years ago, Sentinel-5 with the Tropomi instrument. We're able to pinpoint the sources of pollution. This has been very visible during the crisis because we could pinpoint methane, we could pinpoint carbon oxide. Now, for carbon dioxide, that's more difficult, and will be the next generation satellite. But already, when you see nitrogen oxide and carbon oxide, you got a pretty good measure of where carbon dioxide is going to be generated.
Tell us, what is the frontier on carbon dioxide? Is it today not feasible, or is it something where just the latest generation don't include it, to be able to monitor at real time the emission of CO2?
It's today difficult, but we just approved. I mean, our governing body has just approved yesterday the procurement of the most urgent of the next Copernicus satellite, which will be the one to measure CO2. So it is possible. We are going to build it, but it's going to take another 4 years before we can actually do it.
Okay, so but that will allow us to
pinpoint CO2 emissions. And I think it was on the news that we also were in a position to tell our friends on the other side of the ocean that they were wasting much more methane than they thought. And this is thanks to Sentinel-5P.
Can we continue on that? Where are the current technological frontiers?
We will, in a sense, we will try to be the next step for Sentinel-5 will be we will have more satellites in orbit, so we'll have more up-to-date images of what's actually happening, and we'll try to increase the precision at which, how small the pixel is on ground of what we see. And of course, enlarge the type of gases that we can trace.
Tell us today the resolution. What is
resolution today? It's about 25 kilometers, which is already pretty good.
Okay. Any other areas of improvement? Launcher, space debris?
Well, space debris are the problem we created in terms of environment, and of course, there we are acting. We have a program since a few years called Clean Space, where we act on three areas. In fact, the first one is to make sure we pollute less on ground, and therefore we have introduced life assessment of what is the pollution we create in making our systems, and we're trying to move progressively, for instance, to green propulsion, propellants which are not as toxic as hydrogen, etc. The second thing we do is to avoid to create more pollution. So all of our satellites now are designed and built to get out of the orbit after service and re-enter with a maximum of 25 years on orbit. But even that seems a little bit long, and then we will try to push to take them out of the orbit sooner, or service them on orbit, and therefore making them able to survive longer or to be recycled in another way. And finally, of course, a lot of what's been done in the past will stay up unless taken down. So we have this brand new mission called Arios, which will go and recover a piece of debris and bring it down. So that's what we are doing in that sense. Let me say, I've talked about navigation, Earth observation, telecom. Let me spend a couple of words on something which has been driving our capacity. For instance, the type of coding we use today in telecom on ground was originally developed to communicate with our spacecrafts, which were going even out of the solar system. Now, if you think in the 70s when Voyager was launched, think of what the telephones looked in the 70s, and when did you see a new model coming? So that capacity, it's really driving our inventiveness, our creativity. So we know what's the coldest point of the universe because we made it. In order to see the faintest background microwave radiation, you have to cool your sensors as close to absolute zero as you can. And at the same time, we have to have a satellite which is about 2 cubic meters, no, 2 meters, 2 meters, 2 meters. So it's 8 cubic meters, but it's getting so close to the sun that the front shield gets to about 450 degrees. And to keep it at 450 degrees, we got to eject toward cold space in the back at minus 150 degrees. And this transformation happens in 2 meters, which are packed with electronics that has to survive between minus 5 degrees, minus 10 degrees, and plus 30, 40. So our scientific satellites are really driving our capacity for innovating and coming up with new solutions. And perhaps one of the interesting things is sometimes you go really back to the future. So the paint that protects this solar observatory called SOLO, which is so close to the sun, so it's a heat protection paint that is derived from ashes of fossil bones. So you go to the fossils and you make something that flies in our newest satellite.
Very interesting. Okay, I mean, you mentioned about servicing in space. How far are we from actually producing in space instead of launching new satellites, new additions to the space station? How far are we from actually producing that, which would make it much more efficient?
I think we are, well, already. Let me say the most difficult part of the job is actually to mate two satellites in space, because it's you're actually, especially if you're talking of a satellite which is non-cooperative because it has finished its own fuel, etc., then you're really dancing around, and as soon as you touch something, it will move in a way which you don't desire, and you'll move back in another way. So that is the most difficult part, and we are getting there. As I said, recently there was a refueling done in geostationary orbit. That was a first. We are going to take an inanimate piece of debris and capture it and bring it down. So all of that brings us closer to the moment where we'll be able to do that. And of course, as you said, launching still is one of the very expensive and difficult technologies for us, and one in which we are working on new propulsion systems, propulsions which will actually extract the oxygen, the oxidizer, from the atmosphere, and therefore create a first stage that can actually fly through the atmosphere, and therefore be not having to carry all the oxygen from the start, and be a very efficient way to go up and fully recoverable. And this hopefully will reduce the cost of getting to orbit. Already Elon Musk has done a big step in recovering his first stage, and we're working on that as well. But we gotta go even beyond and be more efficient in going up. So that's one of the big targets.
So that's a perfect transition. I mean, I want you also to ask you some other questions. I could not help realize during the confinement that China actually continued to launch a few weeks ago, and they even announced that they want to have their space station ready by 2023, if I'm not mistaken. Of course, we all saw the Crew Dragon adventure. One of the products I'm sure you also, as an Italian of origin, must be very proud of is the Vega launchers that were probably not enough considered in the past, now are very important in the whole European construct, but was delayed to August. Are we fast enough? I mean, what is the main challenge for the Europeans to really stay? If we are in this leadership position, what do we need to do? Faster, bolder, better? What are the avenues?
In a very mundane way, I would say money. If you look at the difference between European space, it's about 8 billion of government intervention a year. Yeah. US space is about 45, and that's year after year after year after year. So the rate for us, for instance, it never occurred to be very interesting to recover a first stage of Ariane, because we only launch 5 per year. And note, 4 of them are exports. So we launch other countries' satellites. So every time you launch an Ariane is like selling an A320, more or less. Only the aftermarket is no good because it goes to pieces in 20 minutes. But apart from that, it's a fantastic thing. But if you look at the Americans and the Chinese and the Russians, they launch many, many times per year. Now, I think I'm a pacifist, so I'm happy that we're not having large military programs. On the other hand, I think the European Union can certainly step in and do civilly what the others do militarily. We're doing that with Galileo, we're doing that with Copernicus, and we will most likely do something like that with GovSatcom, which will be a constellation of communication satellites, secure communications. So I think we're moving in that direction. I was comforted by the words of Commissar Breton which seems to recognize the importance of space. And space is one of the areas where Europe is still a world player at the maximum level, which unfortunately we cannot say, for instance, for electronics equipment and even sometimes software. So, but again, we are working with our friends in Earth observation to make a digital twin of the Earth with all the data, the petabytes of data that we get from Copernicus. And that will be an enormous stimulus to growth in the area of machine learning, of artificial intelligence. We are working with artificial intelligence for our exploratory missions. And of course, for us, it's a very touchy subject because we like to test everything in every condition. And artificial intelligence is
a lot of experimentation.
Yeah, so you don't know what it will do once it's up there. So you will have to confine a little bit the possibilities. But I think we are a good value, an enormous bang for the buck. So I think
1/6 of even more or less 1/7. So obviously we can be proud, but at the end of the day, also the result count. I mean, I could not help also noticing that you mentioned Google Earth. So we are extracting all these images out of space. Are we? And then you mentioned about software and also components, electronics. Where are the empty corners that where Europe today is dependent on the rest of the world, and what could we do about that? Could you tell us a bit a portrait of where we are lacking this? And this word has become an important word, the technological sovereignty. What does that mean in space, for European space?
I can tell you two areas which for me are really significant. One is in space, of course, and that's electronics. We depend for many of our processors, etc., from US, eventually Japan, or Korea, but Europe is lacking in that area. And when you look on ground, guess who are the two biggest ingester of Copernicus data?
Can't imagine.
Amazon and Google. So that's where and it's not only the capacity of ingesting the data, but it's most of all the capacity of providing access with a metadata, with a service, with a software as a service, which really makes it so that even our startup in Europe with our own data end up having to go through an American service provider to do their job.
So I mean, let's dig deeper into that. Is it because they lack the scale? Is it because they don't have the capacity of agglomerating this data and build metadata out of it for transportation or for imagery? I mean, what is exactly the reason? And secondly, are these platforms paying their fair share? I don't know if you will want to go into this sensitive topic, but are we not a bit naive on that?
Well, I think we may be a bit naive, but I think there are certain we are naive very often in believing that industry does it all. Industry does a lot, but in the US, funding to universities and to developers and to companies does quite a lot. If you read what my friend Mariana Mazzucato writes, you get an idea of how, for instance, an object like a mobile phone depends largely from a lot of funding innovation that comes from government innovation. And in terms of paying their fair share, well, I think Google and Amazon are not certainly paying all the taxes they should when they're over here. But at the same time, I think governments sometimes in Europe are penny wise and pound foolish. You look at the number of papers coming out of universities, American universities, about 50% are not by American citizens. And a very large part is by Europeans. Why don't we pay them a little bit more and keep them here? Why don't we give them perspective in the way forward? So to me, that is really one area where we ought to invest more, and it's not really that much.
No, absolutely. I mean, one of the key members of JEDI is heading the largest research institute in France, and in average, researchers are getting a fraction. What we should not wait for is like with this sanitary crisis, where finally we realize that people in hospitals and nurses are actually getting paid very little compared to what they do. I think it's absolutely the same in science and research. And another anecdote you probably know, I'm sure you know him personally, that I think the head of programs at SpaceX is a German guy, and I think SpaceX must be full of Europeans, of Italians, of French, and so on.
Some of my former students actually ended up working for SpaceX at the beginning. And in reality, I fully agree with you. People realize only lately the importance of people in hospital. I think they should also realize the importance of people who produce the food, distributed it, and those who kept us running with electricity all throughout. But the point on the researchers is we have excellent universities. We create top engineers and scientists, and then we don't pay for that last mile, and all that money that's been invested in this human capital, we actually invested to give a competitive advantage to the others. So that's,
I mean, we may be lucky because President Trump just stopped the H-1B visa system. So hopefully this is an opportunity for the Europeans to keep them. Franco, you are muted.
Yeah, let's not forget that China will still offer quite a bit, and they don't look that much on the visa. But of course, it's not as easy as working in California. That's for sure.
Absolutely. That's also the luck we may have. It's a little bit less attractive to work. But look, let's do a little bit like Star Trek or Star Wars. I think we need to have Franco Ongaro Return of the Jedi, because we want to really keep that short to 20 minutes. We are already way beyond. So let us re-invite you very soon, because I think we just touched the service. Franco, if you agree to come back.
I'll be delighted to. And
I want to ask you about, will we see some private companies enter the space sector like we saw with SpaceX? Will we see a new type of partnerships? What does it take to get the universities and this talent to come back? Maybe one last question on technology, and you mentioned a little bit about the new launchers. Tell us a little bit where are the latest. You talked about the air breathing. Tell us what is also going out in outer space. Are we seeing a really new development going on in this sector?
Well, I think the largest development has been electric propulsion, ionic propulsion. It was there since a while, but now it's really become on its own. And we have we launched a mission last year called Baby Colombo. It will take 7 years to get to Mercury with several planetary assets, but it goes there with 4 electrical thrusters, and thanks to that, we can do the mission. Because otherwise the fuel necessary for used chemical propulsion would have made it an impossible mission to accomplish. So, and most of our telecom satellites are now using electric propulsion and reducing enormously the mass that we have to put on orbit. So that is really a very, very interesting development. Unfortunately, it works on the principle that you push a little bit, but all the time, and you go faster and faster and faster, which is very good once you're in space, but it's going from ground to space where you can't use it because it doesn't have, you need millions of newtons and not millinewtons to move out of away from the Earth. So that's still where we're using World War II technology, and we should really find better ways to do it, and I'm sure we'll do.
Franco, that's a great punchline for the end. So you're a true Jedi. Thank you for your time, for these insights, and we'll see you very, very soon on another Jedi Disruption. Already you can note that next week we will welcome another person who is in the third dimension, because he's the CEO of Volocopter, which is this German autonomous flying cars and drone company, and he will tell us about the future of mobility. That's on the 7th of July at 6 p.m. And in the meantime, Franco Ongaro, thank you very much, and stay safe in space or wherever. Take care.
Thank you very much, Andre. It was a pleasure. Have a nice evening, everybody.